guys, welcome back. So today we're going to be talking about domain and range, still of graphs, but we're going to throw a little twist into it. Now our graphs do not just start and stop at nice places. Now they might have arrows on it, which means they are going to go until they cannot stop anymore out in infinity. So we're going to kind of talk about what that means, what that looks like, and how we write our domain and range with that in mind. So let's get started. For our first graph, we are looking at two individual lines that go straight up and straight down. So for our domain, once again, we're trying to find all of the x values that our graph covers. So if we're trying to think about boxing in our function, we see that our graph hits -3 for the x value, and our graph also hits +2 for the x value. However, our graph doesn't touch anywhere in between this. So for our domain, which I'm just going to write D, the only two x values we see are -3 and +2. So I'm actually going to list those up. So I'm just going to say x equals -3, 2. Since we did not go and touch any of the other points in between, we can't say that our x values go between -3 and 2 because we're not touching any of those points. So in this case, our x values are only those two coordinate points alone. Now let's look at our y value for our range. So if we kind of box this in, we would look at something like this. However, a couple things we need to notice. Where our graph touches those two blue lines, we have arrows. This means that those arrows are actually going to continue past those blue lines. So our range, if we are trying to find the bottommost point or the lowest point that our graph is going to touch, that's going to be a -infinity because our graph continues down in the negative direction forever. So we're going to start with -infinity, and the infinity symbol kind of looks like a sideways 8. And this guy is going to be less than all of our y values. Now, when we use infinities, we will never use the inequality less than or equal to, because infinity is not an actual number that we can equal, because we can always find a number smaller than the number infinity that we chose. So we have -infinity is less than y, which is less than +infinity, because our arrow pointing upwards means our graph is going to continue on forever in the positive direction. So forever to infinity. All right, so that is our domain and range for the first graph. Let's do a couple more practice problems just so we really get a good understanding of what this is, especially including infinities. All right, I am going to skip over the second graph here. If you need some help with the second graph, refer back to the level 1 video that discusses how to find domain and ranges of such graphs. All right, so for our third graph, once again, we can kind of think of boxing this in. So we look at our x values from left to right, but what we notice here is that these two arrows will always slightly continue to go more to the left and more to the right. So our domain for this guy, since our arrow always will continue to slightly go to the left in the more negative direction, we will have -infinity is less than x, since domain is all the x values, is less than +infinity, because our graph will continue always in the positive direction over the x values due to that arrow. All right, for our range, if we look at the lowest and highest values, once again, we run into our arrows, which means for our range, that will span from -infinity, since it keeps going down in the negative direction, which is less than y, since y is our range values, and y is going to be less than +infinity, since that arrow continues up in the positive direction. Whenever we have this idea that our range and domain goes from the negative infinity to positive infinity, we call this, oh, it's a little thick. We call this all real numbers. And this means that our graph covers every single x value and every single y value. So you might hear that term come up here and again, is all real numbers. So that means our graphs go from negative infinity to positive infinity. All right, let's go ahead and look at a couple more examples. For this first one, we have a straight line going left to right. So if we want to find all of the x values that this graph spans, we see that our arrows continue past our box. If we were to kind of zoom out of this graph, our arrows would continue on for forever, which means that the domain for this guy is going to be kind of that all real numbers concept. We're going to go from negative infinity, since our arrows will take us all the way down in the negative direction for forever, which is going to be less than x, which is going to be less than positive infinity, since our right arrow takes us positively for forever. Now, if we look at our y values, we can see that our graph starts and stops at the same place. It does not have any numbers in between what looks like positive 3. So in the case of our range, our y is just going to equal positive 3. It's going to equal that one solid number, since we do not span any numbers in between. All right, for our second example, we want to look at the x values once again to find our domain. What we notice here is that we hit an arrow for our lowest x value, which means negative infinity. But we do have a solid dot at 4. So in this case, our domain is going to start at negative infinity, which is going to be less than x, and it's going to end at positive 4. And since we have a closed circle, we're going to write less than or equal to positive 4. So our domain starts at negative infinity and goes all the way to positive 4. For our range, the lowest y value that it hits is going to be 0. And if we try to box this in once again, we hit an arrow. But in terms of our range, instead of negative infinity, our range is going in the positive direction. So positive infinity for the range. So our range, we start at 0, and since we have a closed circle, it's going to be less than or equal to. We're looking at all the y values, and since our graph goes in the positive direction forever, we're going to end at positive infinity for our y values. So our range is going to be from 0 all the way to positive infinity. All right, let's look at 2 more examples. Okay, so for this first example here, if we're looking at those x values, we hit 2 arrows, which means we are starting at negative infinity, since it will go on in the negative x direction for forever, and we're going to go all the way to positive infinity. So we have negative infinity is less than all of our x values of our function, which is less than positive infinity. And our range, once again, if we draw and kind of box in our functions, we run into both of those arrows as well. So our range is going to start at negative infinity and cover all of the y values till positive infinity. And once again, this is called all real numbers. Okay. All right, final example for this guy. Once again, we want to look at our x values and what they span, but we run into arrows, which means we start and stop at our infinity. So our domain is going to start at negative infinity and go all the way to positive infinity. And once again, because infinity is not an actual value that we can ever equal, we will not use the inequalities less than or equal then. but just the less than inequalities. All right, for our range, this guy looks like it starts at -5, and once we get up high enough, we hit those arrows. So we're going to end in the positive infinity direction, but our range actually has a starting value of -5. It does not go lower than that. And since we have this closed circle here at -5, it actually touches that point. We're going to use the less than or equal to inequality. So -5 is less than or equal to y, which is less than our infinity, since our arrows take that all the way up for forever. And that is how we find domain and range of what we call continuous graphs that go out to infinity.